This Dynamic Earth, the story of plate tectonics. The theory of continental drift. Continental drift is the hypothesis that the continents are moving in relation to each other. This was first proposed by Alfred Wegener, a German meteorologist. Wegener proposed that the continents were once all connected. He called the landmass Pangaea. As seen on a map, the continents seem to fit together like a jigsaw puzzle. This theory was not readily accepted by scientists. As evidence, fossils of the reptile Mesosaurus have been found on the east coast of South America and on the west coast of Africa. Now, this was a freshwater reptile that could not tolerate salt water and could not swim the Atlantic. Further, fossils of warm weather plants were found on an island in the Arctic Ocean where they could not survive, and rock layers or strata in North America match those found in Europe and Greenland. So what force could cause the continents to drift? Part of the answer is seafloor spreading. The seafloor spreading theory was proposed in the 1960s by Harry Hess, an American geologist. His idea is that material is continually added to the ocean floor. The seafloor spreads apart along both sides of a mid-Atlantic ridge. Magma is then forced up and hardens into new crust. Seafloor spreading is the ocean floor moving like a conveyor belt, carrying the continents along with them. The rocks form when magma hardens quickly underwater, blocking the direction of the magnetic field. More evidence to support the theory includes the seafloor rocks that make a pattern of magnetized stripes. This also proved that Earth's magnetic field changes at regular intervals. Rocks get older as you move away from the mid-Atlantic ridge. Plate tectonics. The Earth's crust and upper mantle are broken into sections called plates. Plates move around on top of the mantle like rafts. This is a map of the tectonic plates believed to exist as we know it today. You see the blue one in the middle is the Pacific Plate, where 75% of all earthquakes and volcanoes occur. So the first part is the lithosphere. The lithosphere is the crust and part of the upper mantle. It's 100 kilometers thick, and it's less dense than the material below it, so it floats. The material below it is the asthenosphere. This is a plastic layer below the lithosphere, so the plates of the lithosphere float on the asthenosphere. This is a map that shows the lithosphere and the asthenosphere underneath the crust of the Earth. It also shows the various plate boundaries and the geological features that occur at each of these boundaries. There are two types of tectonic plates. There are ocean plates that are found below the oceans, and continental plates that contain the continents. There are three types of plate boundaries that separate these plates. The first is a divergent boundary. This is a boundary for two plates that are moving apart or rifting. The rifting causes seafloor spreading. Features of divergent boundaries are mid-ocean ridges, rift valleys, and fissure volcanoes. The mid-Atlantic ridge is an example of seafloor spreading and of a divergent plate boundary. The mid-Atlantic ridge divides Iceland in two, with the North American plate moving to the west and the Eurasian plate moving to the east. A convergent boundary is a boundary between two plates that are colliding. There are three types of colliding or convergent plate boundaries. Type 1 is where ocean plate collides with a less dense continental plate. This creates a subduction zone where the more dense plate slides under the less dense plate. Volcanoes occur at subduction zones. This is a map showing the lithosphere or the oceanic plate subducting beneath the continental plate, and the result is volcanoes and trenches if you're in the ocean. The Andes Mountains of South America are examples of mountains and volcanoes created by a converging plate boundary. Second type of plate boundary is an ocean plate colliding with another ocean plate. The more dense plate slides under the less dense plate, creating a subduction zone called a trench. This is an example of a trench where oceanic plate meets oceanic plate. This creates island arc or volcanoes and a very deep trench. An example is the Marianas Trench, which is the deepest point on Earth. The Aleutian Islands are also examples of islands created where two ocean plates converge. The third type is continental plate colliding with another continental plate. This creates collision zones where folded and thrust faulted mountains form. This illustration shows continental crust meeting continental crust, and a mountain range with a high plateau is the result. The best example of this are the Himalayan mountains, where the Indian plate is converging with the Eurasian plate, and the Himalayas are still growing. The third boundary is a transform fault boundary. This boundary is between two plates that are sliding past each other. A feature of this particular boundary is earthquakes that occur along specific faults. The San Andreas Fault is the most famous transform boundary. This is a boundary between the North American plate and the Pacific plate off the coast of California. And this is a picture of the San Andreas Fault. What causes plate tectonics? Convection currents, which are formed in hot magma in the Earth, moves toward the surface, cools, and then sinks again. These convection currents beneath the plates cause the plates to move. This illustration shows how the convection currents in the mantle and the asthenosphere move, causing the plates to move away from each other, which creates the divergent boundary, which adds to seafloor spreading. So Wegener was right. Convection currents in molten magma provides the force that moves continents. This is an example that shows the convection currents as the driving mechanism for plate tectonics. The end.